Hello and welcome. This is Daniel Gutierrez, Editor-in-Chief and Resident Data Scientist of Inside AI News. I'm here today at the 2024 AI Hardware and Edge AI Summit in beautiful San Jose, California, heart of Silicon Valley. I'm going to have my guest introduce himself.
Hi, I'm Vasudev Lal, and I'm a principal AI research scientist at Intel Labs, where I lead a team called Multimodal Cognitive AI. I'm very excited to be here.
Tell me, what are some of the innovations around AI coming from Intel Labs?
Yeah, so at Intel Labs, we've been very interested in training multimodal foundation models, and we do that on large clusters made out of Intel Gaudi AI accelerators, which are present in our Intel Tiber developer cloud. So we've been very inspired by how, as humans, we learn about the world using all of our senses. We have concepts like, we all have a concept of an apple. We understand, the sound that's made if someone bites into it. We understand, the color of an apple. We also understand facts related to apple, like, apples are high in vitamins and so on. So we feel that the same way AI systems also need to be able to thread through different concepts and different multimodalities and different modalities and be able to create this unification of knowledge that's coming from different modalities. So that's what my team is most interested in doing, showing how as we train large scale models using Intel Gaudi AI accelerators, we are able to bring about this concept level alignment across different modalities.
I know that this was a big topic in your keynote at the conference this week. Why are you so excited about the field of cognitive AI?
Yeah, so if you go back 10 years ago, tasks that were really difficult were detecting cats in images or detecting a sentiment in a document. Now, I would call those tasks perceptual tasks. And with the revolution that we've had over the last 10 years, those tasks have become much easier. Now now we have to go to the next level of uh, tasks in the cognitive AI ladder. So the next level of tasks would be that can we interact with AI systems like we interact with natural with humans using natural language? Can these AI systems understand concepts that are spread across different modalities? Can they synthesize concepts that might be spread across multiple documents? And for all of these tasks that we think are beyond perception, beyond detecting objects in an image or detecting sentiment in a sentence, we like to club all of these into this cognitive AI umbrella. And this is where we think this is what's exciting about AI right now, that we've solved the problems, or we made a lot of progress in solving perception problems with AI, but now it's to these higher cognitive tasks.
What are the key projects that Intel cognitive team is running at this time, and how is this advancing with the Intel Gaudi AI accelerators?
Yeah, so right now, for example, we are scaling out our model sizes. We want to train on a lot of multimodal data, so images and text that are interleaved, video and their corresponding language or captions. And by doing this large-scale training, we want to bring about extremely strong representation learning in our models, where we can create these multimodal representations that that effectively fuse the representations that you might have in one modality, let's say just vision or language. And for doing this, we need a lot of compute. And that compute, our team is able, we are fortunate enough to work on large-scale Gaudi-based clusters, which is really critical for powering such foundation models. So that's what our team has been doing recently, scaling up our model sizes on large-scale Gaudi clusters, and we are very excited to be able to work on AI supercomputers that go up to 1,000 Gaudi 2 accelerators and train multimodal foundation models on large amounts of data.
All right, now I understand that you and Andrew Ng have collaborated on a new developer training course on multimodal models. Can you please explain this to our readers?
Yeah, so in fact, the course just came out today. The course is titled Multimodal RAG Chat with Videos, and it's actually a free course. It's hosted by Deep Learning, and it makes use of models that are hosted on a Gaudi 2 cluster in our Tiber Developer Cloud. So in this course, we go through conceptually, how what does it mean to have models that can align the same concept in different modalities, and then using such models, we go through a whole process of showing how we can index video data into a vector data store, and then be able to formulate RAG systems that can leverage such video data. So we couple this multimodal data store with multimodal LLMs, and we are then able to create these multimodal RAG systems. So what these multimodal RAG systems can do is that if you have your own video corpus, like if you have video data in your organization or any other kind of multimodal data, like presentation slides or PDF documents, then you can index such multimodal data and then be able to create a chatbot that can access this data. And we can ground the answers of this chatbot in this multimodal data.
That sounds exciting. And what are the biggest challenges that the team encounters developing and training multimodal models?
Yeah, so my team has been very interested in developing these models from an ethical point of view. Because we recognize that multimodal foundation models are now moving from research to production. So we've been very interested in trying to solve this problem. That how can we probe these models for social biases? How can we mitigate these social biases and so on? So in one of our works that I also briefly mentioned in my keynote, it was a paper that we published at CVPR earlier this year. We create a big synthetic counterfactual data set, so of image text pairs. So in this data set, we vary one social attribute in images. That social attribute varies either the perceived gender or the perceived race of the people featured in the image, but we keep everything else aesthetically similar in the image set. This lets us probe if foundation models have a certain bias towards certain population segments. And what's also more interesting is that we show that if we use such synthetic data sets and we fine tune models on this synthetic data set, we can reduce social biases in models by up to 20%.
That's exciting stuff. I understand your team is training and deploying models on the Intel Tiber Developer Cloud. What's the capacity and how do customers need to get access to it?
Yeah, so within our Intel Tiber Developer Cloud, we have multiple data centers. So even in the keynote today, we featured video footage from one of our data centers, which is in Arizona in Scottsdale. Um, within our Tiber Developer Cloud, customers can get access to either single node Gaudi 2 systems or small clusters like 4 node clusters, 8 node clusters, 16 node clusters, going all the way up to 128 node clusters, which is 1024 Gaudi 2 cards. And Gaudi 3 systems are coming up very, very soon in our Tiber Developer Cloud. And for customers to access our cloud, they just need to go to our URL, which is just simply cloud.intel.com.
And what can people do to get more information?
Yeah, so I would suggest that if you want more information on Intel Gaudi 3, there's a detailed white paper on Intel's website on Gaudi 3. If you want more information on our team's papers and publications, we publish in the top AI conferences, and we often open source our code and models. So I encourage people to use those resources. And if you really want to learn how to create multimodal RAG systems on Intel Gaudi using our Tiber Developer Cloud, go take the course that we just released today with Andrew Eng. And that would be a way for you to put Intel Gaudi 2s to very good use.
All right, great and exciting insights from Intel. Thank you so much for joining us.